In this episode, we talk about actionable big data analytics. Hi, and welcome to ScaleCode.com. My name is Christoph Limplayer, and in this episode, I'm joined by Manisha Sule, who is the Director of Big Data at Linux Academy. So she is one of my coworkers, and the reason that I invited her on the show is because she was working on one of our products that we built from the ground up using big data analytics. So that was one of the very important parts of that product as we were rolling it out. And so the reason that she's on the show is because she's going to be able to share some of her experiences building that from the ground up. And so she's going to be able to answer questions that can help you take that information and then apply it to your own applications. So for example, how can you build a scalable data pipeline that collects data in real time, for example? Or how can you grab that information and make sense out of it for the stakeholders to be able to make decisions or to look at it and see what's going on? Or how can you all do all of that without spending tens of thousands of dollars or without having years and years of experience? So those are some of the questions that we'll be answering in this episode. Stay tuned. Manisha, thank you so much for being on the show. I appreciate it.
Oh, I appreciate the honor to be on the show.
I know you've been really busy building that big data analytics into the platform for the past couple of months, or actually a few months now. And I also know that you've been busy on the weekends. For example, you just told me that you ran a triathlon in not too far away from here. So I know you've been busy, so I do appreciate you taking the time to do this. But to get started, I'd like for the audience to know you a little bit better. So could you tell us more about your technical background and where you come from?
Sure. So I grew up in Mumbai, India, where I did my bachelor's in computer science. And I knew from eighth grade onwards that, yeah, that's what I wanted to do. I wanted to get into computer programming, just do wonderful things with it. And thankfully, I did get the opportunity along the way. I had a chance to work with some, wonderful people, wonderful teams. The dream continues to be able to work with Linux Academy. And I actually started into enterprise software development, more of Java, J2EE. Spent about a decade with Sterling Commerce, which was later on bought by IBM. And in IBM, that's when I made my switch from, core software engineering, software development to big data analytics. And that was also the time when data science, was becoming the buzzword. And thankfully, I got the opportunity to get started on this very interesting field. So my first experience was with Cognos. Cognos is an IBM product. It is majorly into business intelligence, data warehousing, but they were also expanding into more general purpose analytics, collaborating with Watson Analytics. So that's where I started my analytics journey. I then later on actually moved to IBM Spark Center, which is where I got my hands-on experience in Apache Spark. I was performing the role of a data scientist, come an Apache Spark evangelist over there, where what we would do is we would, work with various clients, understand their needs, create proof of concepts using Apache Spark, and help them understand how Spark can fit into their solution. And after that, I came across this very exciting opportunity at Linux Academy, and here I am. I initially started as a big data instructor. So we have launched a few courses on Linux Academy, namely one, of course, on Apache Spark. Then there's Big Data Essentials, Machine Learning. We have one on Azure, one on AWS, and the latest one is a Big Data Specialty on AWS. So do check those out if you haven't had a chance.
And the Essentials one, I haven't gone through it, but I looked through the syllabus and it seems to cover a lot of the trends of what's happening in the industry and how companies can use these different tools to get insights into their data. And so that's the fact of what's going on with big data today. There are a lot of different tools. You have to use the right tool for the job.
Exactly.
And even though you have extensive experience with Spark, oddly enough, you didn't even end up using any Spark for this project here. So we'll find out why and all of that good stuff now.
Yes.
So you joined Linux Academy a few months ago. I think it was over the summer of last year. Correct me if I'm wrong.
That's correct.
And then
in the summer of last year.
Perfect. And then you moved on to create courses for Linux Academy. And then earlier this year, I think it was in January, very early of this year, you got a phone call that said, we've got a very exciting opportunity. We're going to build a new product from the ground up, and that product is called Cloud Assessments. Can you tell us more about that product?
Of course, yes. So Cloud Assessments is, like Christoph said, a brand new product launched by Linux Academy. And it serves really two purposes. One is for the student. So, for example, if a student is wanting to target a particular job or a particular skill level, we provide assessments using which the students can measure up to where they stand with their skill level. If they are behind, we offer labs which let them learn, or we offer training which get them up to speed. On the other hand, there are employers who may use this tool as recruitment tool for screening applicants. But the main theme, I think, behind cloud assessments is the concept of lean learning. And what that means is, to offer the right content to the right learner at the right time in the right way. So let me explain what that means. By the right content, what I mean is we do not want the student to get bogged down by too much. So statistically, we have this huge popularity for massive online courses like Coursera, edX, etc. And you would be surprised to know that the rate of completion for these courses is actually less than 10%. And the main reasons cited for students dropping out are either it's too difficult for them, or too basic, or it's just too much and they don't have the time. So, what we want to do in cloud assessments is just offer the right content, which is just exactly what you need, no more, no less, in the right way. So, what does the right way mean? We don't just have, quizzes or just plain question answers. We actually have live labs. So, for example, if you want to test your skill in AWS, we have a lab that lets you configure through a EC2 server or elastic load balancer. And we have a system that is able to grade each and every configuration step you take, and that tells you, how much you got right, how much you got wrong, and enables the learner to exactly do what they want. So that's the whole concept of lean learning about cloud assessments.
So you have students who go in and they can take assessments to test their skills, and then they can take labs. Where does analytics play a part into that entire platform?
Yes, so let me start by explaining the different types of analytics. We have something called descriptive analytics, predictive analytics, and prescriptive analytics. Now, descriptive analytics allows you to understand the current state of affairs. So, what that means is in this case, you can understand how your customer is using your product, whether the customer likes the product or not. So, for example, for an assessment, we can determine what is it that they like about the assessment, what is it that they don't like about it, what are their preferences, what would they like to see improved. So this helps you in not only improving your product, but also in marketing and sales. Another type of descriptive analytics will be to understand a group of students who are, let's more likely to use it more based on maybe their skills, their interests, maybe their job title, the industry that they work in, so on and so forth. So it's something that gives you an immediate view into how your product is being used. That's descriptive analytics. The other one is predictive analytics. Now, this is more of a machine learning or a statistics use case where you are able to uncover hidden trends or hidden patterns or correlations between usage of your product. Again, the underlying outcome is either to improve your product or to retain your students. You may be able to uncover a trend where there are students who are more likely to terminate their membership. What you can do is take corrective actions to prevent such situations. So that is predictive analytics. And prescriptive is just taking it a step further. So what action should you take to achieve a certain outcome? Now, under this category, are also something called recommendation engines. So when I say the right content for the right learner, that's where a recommendation engine plays a big role. So, based on a student's lab history, how many labs they have taken, based on their assessment history, or based on their just user profile, we're able to make recommendations based on the whole collection of data, the student usage that we have. So there are several analytics use cases that ultimately, help you improve the product, help you in making strategic business decisions, help you in selling it to the right people, to market it to the right people. So ultimately, the goal is to benefit your product.
And that's what I find so fascinating about this story, because when you think analytics, especially big data analytics, you oftentimes think, okay, so this is for established companies that already have massive amounts of data, massive amounts of customers, and can derive value from it. But in this case, that's not at all what's going on. What you're saying is there are smaller use cases. For example, how can I tell what is engaging to my users and what isn't engaging? Where are customers dropping off in the user experience? And so when you're thinking about startups of all sizes and all industries, e-commerce, mobile applications, whatever it is, you can apply these kinds of use cases and this simple analytics to get a result that benefits you. You don't have to be a massive corporation. And in fact, I mentioned that you started working on this sometime in January or maybe even early February. What was the life cycle of that project?
All right, so the life cycle was briefly divided into 4 to 5 phases. So the first phase was the infrastructure phase. In this phase, we determine what's the technology to use, what our data collection pipelines are going to look like, how we're going to process the data, what is our data store going to be. Since you may have heard that the data lake term is synonymous with everything big data. So the question was, do we really need a data lake, or do we have a subversion of a data lake, and things like that? So all those decisions needed to be, first of all, proved that it's going to work for us, and then implemented and then tested. Then the second phase is reporting. So once you have your infrastructure in place, once you have your data pipelines in place, your data is flowing in, you have your data stores that are collecting your data, then comes using that data. So again, there are two to three types of using that data. One I would call is just straightforward reports, where you just execute straightforward queries on your data stores. So for example, if you would like to know, how many users have signed up, but they are still inactive, meaning they have not taken any assessments, they have not taken any labs, they're not really engaged with the product. So that is one example of reporting. Another may be to find out who are your student leaders. So who is really doing a great job in staying engaged, as well as who is your highest scorers. It's a way of motivating students and users to make better use of the product. So that's the reporting side of it. Next is analytics. So analytics can, again, as I described, has a descriptive and a predictive part. In descriptive, what we use are more like dashboards with graphs and charts, which lets you not only get historical trends, but also real time. Real time is very important in today's industry, because your organization has to be able to react to real time events. And so in our architecture, we have provisions of accommodating both real time as well as historical descriptive analytics. So under this category are things like dashboards, and we have used AWS QuickSight to use that. Along with just dashboards, you also have the capability to slice and dice, so to go to a certain granular level. So for example, you want to analyze your geography. Which regions are your majority of students coming from? Is there any dependencies between particular cities versus some other countries, and so on and so forth? So your descriptive analytics solution has to be able to correlate all these different items and let you slice and dice the way you want to. And then the fourth stage is predictive analytics. So this is where machine learning comes into picture. And really the goal of machine learning is to, find hidden patterns or correlations that are not evident to the plain eye. And one important concept about machine learning is that it needs data. So even if you have a very clever machine learning algorithm, and on the other hand, if you have a much larger data set, always the algorithm which has been trained with a much larger data set has better chances of performing and predicting accurate results. So under this phase, really your volume and your quality of data is very important. But yet, in our case, this was a difficult situation because we were building our analytics solution at the same time that cloud assessment was being built. So what that means is we do not really have real data, right? Plus, there is a lot of fluctuation. The requirements are changing, data formats are up for grabs. We do not have our data ingestion mechanisms finalized, and not to mention data noise that comes in when you're not typically constructing a product from scratch. There's a lot of testing going on. So we had to be sure that we are differentiating and not polluting our pipelines with noisy data. And then the fifth phase of the product is maintenance and monitoring. And then of course you repeat. You don't just do it once and be complacent
Right.
about it, right? There are many ways to go revisit. You can go revisit your infrastructure decisions. You can go revisit your pipelines, the way they are structured, your data formats. Predictive analytics is a continuous improvement process. You're always tweaking and tuning your machine learning algorithms. So that's when repetition in cycles is very important. But on the other hand, even monitoring, since you have so many different pieces and moving parts all coming together, it is very important to monitor, and it is very difficult, complex to monitor all these different moving parts to make sure that each one is doing its own job and they're all coming together for delivering the big picture.
How long did it take you to go from that first phone call saying we're shifting your focus to this to something that was able to go in production?
So we had a very strict timeline, and I would say it was about 6 to 8 weeks. And that 6 to 8 weeks included learning the technology. So as I told you before, I have a strict Apache Spark background. AWS is something that I had just started picking up while in Linux Academy. But AWS was our choice, and really there were multiple reasons. The first one is AWS, takes care of all the nitty-gritties for you, right? Things like scalability, fault tolerance, high availability. You take these things for granted when you're using AWS. Instead of having to create your own Hadoop clusters and installing Spark, and then plus integrating it with multiple other products to build an ecosystem, AWS just makes it very easy for you to use these very performant and efficient services. And we're going to talk about all the services that we used later on. But I want to get this message across that AWS was the solution for getting us up to speed in such a quick and efficient way.
So let's break this down. How are you collecting all of this data that you were talking about previously?
All right, so on data collection, we stick to the big data Lambda architecture. What the Lambda architecture tells you is that you have three layers. First is the real-time data collection. Second is the batch processing. And third is a serving layer. Now, what real-time means is it gives you an idea of user behavior with respect to time. So what is a particular user doing at this very particular second? Versus batch processing gives you a whole picture of what the user has done over a period of time. And then you combine real time to batch in the serving layer to give you the best analytics. So our architecture was based on this Lambda architecture where we have three layers, batch, real time, and serving. And plus, on top of that, we decided to go the serverless route. So by serverless, what I mean is you as a developer are free to just focus on the code or the development of what you want to do instead of worrying about your servers, instead of worrying about how to monitor those, how to maintain those, how to patch those. You just focus on the code. And again, AWS serverless services like Kinesis, Firehose, Kinesis Analytics, Athena, QuickSight. This was the first time that we use them. Of course, there were a lot of proof of concepts that we tried before we, delved into. So that's a very important phase that was a part of our life cycle. That instead of just diving straight into a particular service, you have to first ensure that it first fits your use case.
And so you mentioned that there's a batch layer, which is for historical purposes. When does it make sense to use that versus the other one, which is the stream or the speed layer, which collects real-time events? How do you know when which one makes sense?
Right. So for batch processing, the ultimate goal is to compute historical trends. For example, if you want to understand timeline, how which months are busier for your product, or which is a particular geographical region that has the highest activity, or how is a particular student faring for a particular assessment or a lab, or even to determine how effective is a lab uh, crucial to a student's success. So for all this information, if you want to analyze this, what you need is a master data set, right? And so that's what your batch layer does for you. It collects and preserves your entire data collected over time, which you're able to then query and provide these different results. Whereas on the real time side, you want to know what is your product usage looking at right now, right this time. So how many students at this time are taking your test? Or for example, how many of your labs are being used at this particular time? Or what is your time lag between an assessment getting ready versus an assessment being graded? So if you want to get a real time picture on how your product is used, you want to capture all those real time events as and when they're happening. And if you want to determine historical trends or get a more whole picture on how the product is being used, you consider batch layer processing. And ideally, what you do is combine the two. You combine real time with batch to get the big picture.
How do you even collect real-time data, though? How do you grab that information and then put it somewhere else? How does that work?
All right, so we will go to some of the services that we have used in this case. For example, Kinesis and DynamoDB. So Kinesis has a provision of streams. And when you go to Kinesis streams, there are multiple ways that you can read and write to Kinesis streams. So Kinesis streams can be written to by external applications. That's what our cloud assessment website and our cloud assessment engine does. They use the AWS SDK API to write events to Kinesis streams. This is how we capture real-time data. So when a student is taking an assessment or when a student is taking a lab, the different events, for example, the start of an assessment versus the completion of a lab or the completion of a test or the grading of a test, all these are sent as real-time events to the Kinesis stream. Similarly to DynamoDB, when an assessment is completely graded and finished, that's when an entire picture of the assessment or the student's performance on that assessment session is stored in DynamoDB. And Kinesis streams as well as DynamoDB streams can then further be processed by things like Lambda Functions, or you can even have your own custom logic. You can send them to S3 for larger collection, and also can be processed using Athena tables.
So if you're not familiar with these services, be sure to check them out. They are all AWS services, and I'll also have a description of them below the video so you can look them up. But Manisha, you already mentioned a few different services like DynamoDB, S3, Lambda, Kinesis. Can you list all of the various services that you're using in this architecture?
Sure. So I would highlight the fact highlight the fact for serverless being that using serverless you only have to pay what you use.
Right.
So if you compare serverless to things like EC2, an EC2 server you have to pay by hour, whereas on serverless you only pay as per your usage. So for example, in Kinesis stream, the unit of scalability is called a shard. And a shard allows you to do at least 2 megabytes of data per second for reading and 1 megabyte of data per second for writing. Now, depending on the data that is going in through the Kinesis stream, that's how you are charged versus, a constant charge for just a particular service. So cost is one factor that puts serverless on top of a managed service. The other thing is flexibility. You do not have to worry about setting up clusters or adjusting them to scale your application. Things like Lambda, they automatically scale as per the amount of data that is being processed through Lambda. So to go back to your question, Christoph, the serverless services that we have used consist of S3, DynamoDB, Kinesis Streams, Firehose, Kinesis Analytics, Athena, QuickSight, SNS, and the most important of them all is Lambda.
Is there anything that you tried doing that didn't work with the serverless architecture?
Now, there were many situations where we had to rethink our strategies. For example, when you consider Athena, so Athena is actually a very new service, and it's an interactive query service, which is serverless, of course. And what it does is it lets you read data that is in your S3. So let's imagine that you have a certain set of data stored in an S3 bucket. What you can do is in Athena, you define a schema over that S3 bucket, which lets you create a table, which is of course only read-only. And then using the table, you can execute queries. Now, the question that we had in our minds is that typically Redshift and RDS are, managed AWS database services, which obviously have been proven to be very flexible when there are complex queries like joins or using time windows. And we were not sure if Athena is going to be able to support that. Also, we were not sure if using Lambda functions we can execute queries in Athena. But ultimately, we did find a way to do that, and the route was using JDBC. So in Athena, you can query using a JDBC adapter, which just restricts it to Java for now. But also, if you do want to use Python, you can also use third-party libraries that convert your Python calls to JDBC calls. So the point was that, yes, there were situations where we were contemplating the usage of these other alternative managed services. But I think AWS, has a good idea of how their services are meant to be used and make provisions so that there is no use case that is blocked. And so ultimately, we did stick to just Athena using JDBC in our Lambda functions.
So that's a question I see quite often, especially since we have serverless content at the Linux Academy is, okay, this sounds really good. What's the catch, or what can't we do using these serverless services? And so you hit some of those on the head there. And I know also that sometimes you can lose a little bit of flexibility because they are managed services for you. You don't have to manage them, which means you don't oftentimes have to configure them as much. You still have to configure them to some degree, but you may not be able to go into the server. Actually, you won't be able to go in the server and change some settings at that level. So sometimes you could lose a little bit of configuration there. What do you think about that?
Yes, definitely. In fact, another example is the timeout on a Lambda function. So Lambda functions are typically meant to be used in a microservice architecture, right? And the idea behind microservice architecture is to build your application is as many independent services rather than one large monolithic code base. And so in the spirit of those many little independent services, your code is not supposed to be a long running job, but instead something that is, executed and completed in a short amount of time. So that the timeout on your Lambda service is currently set to 5 minutes, and you cannot exceed those 5 minutes. So what that does, it puts a restriction. What if you have a very complex process that goes above 5 minutes? What do you do then? The alternative to such a restriction is just using putting your Lambda code in its own container on Docker and running the Docker on EC2, and that lets you create your own Lambda service. But again, it's not the same as a managed Lambda service. At that point, what you lose is the ability to monitor, the ability to integrate with things like API gateway. So there were always pros and cons, like you said, of losing flexibility versus gaining integration points.
Now you mentioned a few different services. You talked about how you're using Kinesis, Lambda, all those different services. Can we break it down just a step further and figure out, okay, so I know you're using Kinesis, I know you're using Streams and Firehose for Kinesis with Lambda, but how does that work? If someone's never used Kinesis before and they've never used Lambda, how do those two services work together and why did you use them?
Sure. So the purpose of Kinesis, like I said before, is to capture real-time data. So a Kinesis stream can either be a producer or a consumer. Now, in case of a consumer, you have apps that write to your Kinesis stream. And a Kinesis allows your data to be retained for 24 hours. That's by default. It can also be increased to 7 days. And plus, if you want your Kinesis stream to be, consumed by multiple applications down the stream. For example, you're getting your real live data in a Kinesis stream. Now, the next step is to process this data. And so to process this data, let's say you have a bunch of Lambda functions that perform some kind of logic on your data and then finally persist it to S3. Now, what if you have multiple Lambda functions that are reading from the same Kinesis stream? In that case, there is a pattern called a fan out. So what you do is you connect one Kinesis stream to write to multiple other Kinesis streams. In that way, what you're doing is you're increasing your read throughput. And so there's a lot of flexibility given just one single source of data. You can process it in multiple ways. And this was the flexibility that we were looking for. We wanted real-time data plus the flexibility of being able to process it in multiple ways. And the combination of Kinesis and Lambda was perfect for that.
Then the next service was DynamoDB. How does that, so now we understand how that data is moving between Kinesis and Lambda, but how does DynamoDB play a role into that?
So DynamoDB, the advantage of DynamoDB is that it is schemaless. And that was exactly what we wanted while our product was being built. So let's say, for example, we want to store a user profile in DynamoDB. Now, a user profile has to be schemaless since there are multiple user attributes that are not present for every user. Also, you may want to add different attributes at different times. For example, let's say social media links. You may not have it today, but as your product matures, you may want to add that information. And hence, that's what DynamoDB gives us the flexibility to be schemaless and add, subtract data as you grow. Plus, DynamoDB also has the support for streams. So what that allows you is similar to Kinesis streams, where you can connect your DynamoDB streams to Lambda functions. And so whenever there is an update or an addition or a deletion made to your DynamoDB object, a Lambda function triggers and processes that change. So again, that fits into the real-time processing story that we have talked about.
And again, DynamoDB is a NoSQL database, and how it compares to something like MongoDB or another NoSQL databases, it's serverless in the sense that you don't have to manage the servers behind that. So if you want to spin up a MongoDB cluster, you have to manage that cluster yourself. Whereas in AWS, if you use DynamoDB, you can just say, provision this amount of capacity in terms of read and write throughput, and Amazon promises that they'll handle that for you. So you don't have to manage all of that, just in case they don't know what DynamoDB is.
Correct.
So now you've got DynamoDB, you've got Kinesis, and you've got Lambda. We also have a service called Amazon S3, which stands for Simple Storage Service, where you can store all kinds of different objects. How does that differ from DynamoDB, and why did you use both of those services?
So S3 has a great integration point with things like Athena. And Athena was our query service that would ultimately be fed into our dashboards. Now, S3 is also touted to be very powerful, powerful enough to replace the HDFS that is used for big data a lot. So HDFS is the core component of Hadoop, which is the Hadoop distributed file system. And the goal for HDFS is to provide unlimited number of objects and volume of data, to be able to store unlimited number of objects and volume of data, to provide high bandwidth, high throughput limit, and also native support for versioning. So all of these things are provided by S3. On top of that, you do not need to pay extra for data replication. That's what S3 takes care of under the covers. Also, S3 natively is supported by things like Spark and Hive and Presto. So even though we do not at this point use Spark, but there will definitely be a need, as we evolve our analytics product and add more sophisticated intelligence to it, we will be using Spark more for machine learning advanced algorithms. And so S3 is this perfect solution to act as a single source of data. So S3 can also act as a storage for unprocessed data, also can be used to store process data. What that means is when we have our real-time events coming in, we dump them to S3 as one straightforward pipeline. And that is to make sure that if anything goes wrong down the pipeline, down where we are processing the data, we still want to be able to have a backup for the original form of data. So again, S3 is used for that. S3 is used to store processed data. In fact, we have a decoupled architecture where the unit of data, process, and store is considered as one unit. And there are several of these three: data, process, store, that where store represents S3. And once you have various forms of data stored in S3, there are multiple use cases that can plug into these different buckets to ultimately provide things like reporting and analytics.
You mentioned data lakes, the term data lakes, a couple of times so far in this episode, and I think that kind of ties back with Amazon S3 here. Could you describe what data lakes is in case people don't know what it is?
Sure. So data lake is very much used in terms of big data, and what it represents is just a large collection of data in any format. So it does not demand that data should be processed in a particular way. In fact, data lakes are schemaless, and that's the direct contrast to a relational database or a data warehouse where data has to be structured in a particular way as defined by the schema. So data lake really is just this big, massive store where you just dump your data. And the reason behind is that um, when you are writing from the data lake, that's when you apply your schema. So for particular use cases, let's say we have a machine learning use case that wants to look at the correlation between a student's skill set versus a student's assessment scores. At that time, you will apply a schema on the data lake and read only that particular information. So you will only read the assessment history for the student, only the assessment score for the student, and then ignore the rest of the data. So that's how a data lake is meant to be used, that it has all of the data, but you do not really need to apply a schema when you're writing to the data lake, but you apply a schema when you're reading it.
So how do you pull data from it though? If it doesn't have a schema, you're just dumping the data in there. How do you even know what data to pull out of it or what to do with that data?
So we have these pipelines consisting of Lambda functions, which pull out the data and process it into a more schema-oriented data. So for example, let's say computing a student leaderboard, right? To compute a student leaderboard, we want to look at all the assessments, all the scores, and also the time taken by each student on the assessment. And in that case, what we do is we have a Lambda function that reads data from the data lake. Now, again, the data lake is separated out into different S3 buckets. So we have an S3 bucket for assessment history, another for lab history, another for just user profiles. And this Lambda function is now able to read from these different buckets, join the data together, and exactly give out the top scorers based on their score as well as the time taken to complete their assessment. So it's a pipeline consisting of your Lambda, which again writes to S3. So really S3, as I said before, it is our store for processed data as well as unprocessed data.
You can also, I know that with Amazon S3, you can store those objects and it can grow a lot. So they call it infinitely scaling. Now, if they can actually infinitely scale or not, that's a question for debate. But you have other features with S3 that are very attractive for this type of data or data in general, such as you can enable versioning, right?
That's true.
You can have versioning for Amazon S3. You can also have data replication. It has a lot of high bandwidth and throughput. And it also has something like called lifecycle transitions. Can you describe how you're using some of those various features outside of just storing objects? And are you using any of those features?
So S3 is more useful when your data is being frequently accessed. And of course, like I said, there is no need to pay extra for data replication, but you also can make use of things like Glacier for archiving your cold data. So after a certain point, since our product is relatively new right now, we do not necessarily have the need for archiving cold data, but we envision a point in the future where, let's say after a year or so, we are now able to archive this, unprocessed raw data into Glacier, but at the same time keep it available for further needs if needed.
And you also mentioned Lambda a few times by now. Whether people are familiar with Lambda or not, can you describe a little bit more of how it works? I know they have functions and you can feed Lambda functions and they execute the functions, but how does that work?
Sure. So Lambda is really the heart of our serverless architecture. They also represent microservices. What that means is that you have to divide your functionality into separate independent pieces of code. Now, the advantage to this is that they can be written, tested, as well as deployed independently. So the way you go and configure Lambda is in a variety of languages that are supported. So you have support for Java, for Python, and for Node.js, and I believe Ruby also. So whatever unit of code you have, you can upload that code into your Lambda. Further, you can set up triggers. So let's say you want to trigger or invoke this Lambda function when a Kinesis event happens or a DynamoDB event happens, and even S3. So in case of DynamoDB, let's say when your user profile is updated by maybe a social media link, and at that point you have a Lambda unit of function that goes in, reads that social media link and fetches some additional details. So that's a great example of how you can have your Lambda unit of code respond to an event. Once it responds to an event, it does its unit of processing, and later on it can emit out the results to, again, various different sources. So it can write to Kinesis streams, to Firehose, to Redshift, to S3, to RDS. It is a pretty large variety that you can output your results to. But the important thing to remember about Lambdas are that they are event driven and that they are stateless. So you do not maintain any state. Whatever storage you have that is outside your Lambda, and in this case your storage can be S3 or DynamoDB or Kinesis. All you do is you take the data from the storage, you do your processing, and then you output it out to a different format of a storage. And that's your Lambda functions for you.
There's one other service that we haven't really touched on too much yet, but you've already mentioned a few times, and I know it's being used, and that is Athena. What is Amazon Athena?
Great question. So Athena, like I said, is a relatively new query service, and it is meant to be more of an interactive service to quickly query patterns in your data. Athena is also supported by Presto. Now, Presto is the distributed SQL processing engine in AWS. And what that allows you to do is to query large, vast amounts of data in relatively quick amounts of time. So Athena is again a very powerful serverless service that lets you query vast amounts of data. Now the way we are using Athena is to apply a schema on our S3. So whatever data we have in our S3 buckets, Athena reads from those S3 buckets and is able to create tables which can then be queried. Furthermore, these Athena tables can then be plugged into QuickSight. Now, QuickSight is AWS's visualization tool. You can create typically dashboards and graphs using QuickSight. So Athena is a very actually important component in our descriptive analytics solution, where it acts as a query service. It has advantages of being able to yield results very fast because of the Presto support, and has the advantage of integrating into QuickSight, which really lets you create dashboards very, very quickly.
So does Athena actually have the visualization aspect of it, or do you have to use something else to pull those queries out and actually visualize it?
Right. So QuickSight is what integrates with
Okay.
Athena. And so under the covers, in QuickSight, whenever you create a dashboard, there is an Athena query that gets executed and fetches this data, which is then displayed by QuickSight.
Now, Manisha, we're starting to run out of time here. I know there's a lot more we could be talking about, but is there anything specific that you think we might have missed or that you should mention as it relates to this?
So along this way, there were a few learning lessons that we learned, and one of those is that we learned was, don't let perfect be the enemy of good. So what that means is you can start small. Don't have a very grand vision that you're trying to tackle, because that can be very overwhelming, challenging, and instead it's better to have small successes and then build into a more grand vision. So following the agile methodology, creating smaller goals, creating proof of concepts to first establish and ensure that you're going to be able to reach those goals with the technology that you have chosen, that is important. Then typically in a big data situation, you have to avoid failure of collection. So what that means is uh, don't worry that if you do not have data today, your pipelines are not going to work. That's not the case. Have your pipelines ready so that when your data starts rolling in, you are in the position to start making use of those data as they roll in. The other thing is it's better to have a diverse set of skills for your team. Especially in the microservices architecture, it gives you the independence to develop and deploy in an independent fashion. So you may have developers who are experts in Python, some maybe in Java, some in R. And really each of these technologies have their own strengths and weaknesses. And having a diverse team will help you in utilizing all these different technologies. The other thing is, especially for a big data project, is to have leadership to be, data literate. It's very important that they understand how data can be used to, improve the product or to make strategic decisions. And in that matter, we have been very lucky to have Anthony as our leader, who has, the vision of how we can use data. Also, even after you have created your product, the last but not the least is evangelizing. So if you have a product but there's nobody to use it, right? It's meaningless. And in this case, you may have to go the extra step of training your team to use the tool. So let's say if you have dashboards created, you have to train your team on how to make best use of those dashboards. So that's where all your evangelizing efforts need to be in place, where you are conveying to your company or to your group how to make best use of the product that you created.
Manisha, thank you so much. I appreciate your time and your experience in sharing this information. If people have any questions or if they're interested in learning more, how do you recommend they do that?
Sure. So we here at Linux Academy are also have a big data team that can answer any of your big data questions. We have, again, a diverse set of experience on AWS as well as Azure. So feel free to reach out to us on community, Linux Academy community, and also through Scale Your Code.
Thank you so much for tuning in, everyone. If you have any follow-up questions as well, or if you just want to leave a comment, thank Manisha for her time. Please leave a comment below this video. Otherwise, thanks so much for tuning in. And Manisha, thank you so much.
Thank you, Christoph.